Hey guys, so this is how your classes might work for the time being. I'm not going to edit these videos at all because you have the control in terms of stopping it, rewinding, fast forward, fast and slow. So I don't really see there to be much of a point. So yeah, let's just get started. So 5H, which is the next thing that we were going to do if we were still at school and school holidays didn't start early, we have done inverses before, except this one's more so specific to your exponential and log functions. So when I introduced log graphs, I think it was, we had already done exponentials. So our exponential graphs would look something like this. So you've got your horizontal asymptote, and then it might run something like that. So let's say that is e to the power of x. And we know that the log graph is actually an inverse of this. So it's got its vertical asymptote instead, and we'll run something like that. So this one, let's just say it's the inverse of f of x, so f negative 1 x, it would be that one there. So hopefully we can see that it's reflecting in the line y equals x, which would be this line here. I know the scale's a bit dodgy, but hopefully you can see. There we go. So that's our exponential, and our log is the inverse of it. So we should already know these things already because they apply to any inverse function, but it's pretty important, so let's just go over it again. So we can see that with the graph that I drew just before, the graph's reflected in the line y equals x. The x and y intercepts swap, that's the second dot point there. If we go up here and you work it out, you'll see that the y-intercept for this one is actually 1, and the x-intercept for this one is 1 as well. So they do swap around. That's what I mean by your x and y values swap, but it's not just those specific points, it's any point along the line. They're just some special ones that can make our life a little bit easier later. And the last thing for now is that the domain of your initial function, so just f, is the same as the range of your inverse. So again, your x's and y's have swapped over, and the same sort of thing with the range of f and the domain of the inverse, because your x and y's are swapped over. Alright, so let's start having a look at our examples that you should have in your booklet. Right, now let's do this one first. So we've been given this log graph, and all it wants us to do is sketch it. So this is something that we've done in class before. The first thing we need to do, just 1 second, sorry. The first thing we need to do when sketching it is work out where that asymptote is. So this is a log graph, so we should have a vertical asymptote, and we can work out where that is with this bit here. So 2x plus 1 equals 0. If you solve that, x is going to be negative 1/2. I'm going to try to do this to scale as sort of possible, because we are going to end up sketching the inverse on it and it can get a little bit confusing. Let's just make half here. Okay, make sure you label your asymptotes. There you go. Okay, so the next thing we need to have a look at is whether there's been any reflection. So I can't see a negative out the front. I can't see a negative in front of our x either. So what that means is our graph should go something like that. Okay, so before I put that line down, I want to work out where my x and y intercepts are, because I don't want to put them in the wrong spot and then have to draw my graph again. I don't really have much room here. I might do it up the top. And as you guys know, when you want your x-intercept, make y equals 0. When you want your y-intercept, make x equals 0. Same with any graph. So I'll just do those two right now. Okay, so if you look at this part here, look at this log E1 kind of thing. E to the power of what gives you 1? It's 0. So that bit just becomes 0. So what we're going to have is 2 times 0 minus 6. So our y-intercept is minus 6. There we go. So we'd be able to pop that one in here. So let's do it just to scale as possible. So minus 1, 2, 3, 4, 5, 6. And we need to find our x-intercept as well. So I'll go back up here. I'm going to put down every single step, but you don't have to do it when you're doing it. Okay, there we go. So that's our x-intercept. Because this looks like a bit of a weird number, let's try to work out what it might actually be. So remember, Euler's number is like 2.7. Let's just say it's 3 to make it easier for us right now. So we have, what, 3 to the power of 3. So 3 times 3 is 9, times 3 is 27, minus 1 is 26, divided by 2, which should be about 13. It's going to be a little bit less than 13. And that's not going to work in terms of the scale I've done here because there's not enough. But let's just do it as, I don't know, accurately as possible. So we'll make it all the way out here. There we go. And the line should look something like that. That was dodgy, sorry. Something like that. It keeps on going that way and it keeps on going that way. So I've done the first bit. Let's go over to II. So it wants us to state the domain and range. It already gave us the domain at the start because it gave us in functional mapping notation here. So here's our domain. We can pretty much just copy that, but we can see it when we look at the graph as well. So it starts at the asymptote, doesn't include that number, and continues on to infinity. So our domain of f would be from -half to infinity. And we can have a look and see what the range is as well. We can see that it goes all the way down to negative infinity. This is going to keep on going up as well. So our range is going to be R. There we go. All right, now finding the rule for the inverse. We're always swapping those x and y values, and if we want to give a rule, we'd normally make it y equals, wouldn't we? So we're just going to follow those two steps. So I'm going to swap x and y first. And now I want to make sure I can rearrange this to have my rule y equals. Okay, so there's our rule, except this doesn't show us that it's actually an inverse. So let's use the correct notation. This is supposed to be the inverse of the function that is called f. So we will show that using this. There we go. Alright, cool. So we've got the rule. The next thing it's told us to do is sketch the graph of the inverse on the same axis. So we need to sketch it up here in your books. We could use this rule to sketch it, except you don't necessarily have to. I wouldn't do it because it kind of takes more brain power. If we've already sketched your initial function, we can just reflect it in this line, y equals x, just here. So we've been given these 2 points that we need, so our y-intercept and x-intercept, we can just swap them. So this point here is going to become the x-intercept of the inverse, and this point here is going to become the y-intercept of the inverse. So let's just do that because it's going to be way quicker. I'll use a different color so you can see which one is which. Okay, so this is going to become an x-intercept, so minus 6. 1, 2, 3, 4, 5, 6. And this one here is going to become the y. There we go. I forgot about the asymptote as well. We need to make sure we're putting that one in there. Now that was at x equals minus 1/2, so it's going to turn into y equals minus 1/2. So that would be going along here. And make sure we're labeling it. Cool. Now it should look like when we sketch the line, like we can just follow the dots. It's going to go like that. It should look as though it's reflected in that dotted line there, y equals x. Keeps on going that way. Keeps on going that way. And I need to make sure I label my axis as well and actually show which graphs which. So that's my x. That's my y. The black one is f of x, and the blue one was its inverse. There we go. The last thing we need to do here, because we've already done for this one, we just need to state the domain and the range of the inverse. So we already stated the domain and the range of our just initial f function. So we can use what we spoke about, or what I spoke about at the start. So we're after the domain of the inverse, and the domain of the inverse is the same as the range of f. So we can just look up to where we answered that up here. The range of f is R. Okay, so if we look at our inverse graph, we should see that the domain is R, which it is. There you go, and the same with the other. We want the range of the inverse, and that's equal to the domain of our initial one. Okay, or you could just look at the graph. You don't need to have done this first, but if you know this, it makes life a lot easier, because it makes life a lot easier. Some multiple choice questions involve stuff like this, and if you already know that the domain of your inverse is equal to the range of f, and these ones as well, you can get those questions done really, really quickly rather than putting any working out in. Okay, so we want the range, and that's going to be from -1/2 all the way to infinity. This one over here, I'm not actually going to do this for you right now. I want you to try to do it by yourself. With this one here, we started with a log. We found the inverse, which ended up being exponential. So you could probably guess, hopefully, that if you're starting with an exponential and you want the inverse of that, it's going to be a log. Okay, now this one here, when you sketch it, like we're following the exact same steps as what we did with this one. When you sketch it, they will intersect. For now, don't worry too much about finding that point of intersection. We'll do that a little bit later. But something that I do want you to know is that the original function, so f of x, wherever it intersects with its inverse is going to be on that line y equals x. Okay. Yeah, so have a go at those ones by yourself. I will do those exam questions on the back though. So try to do these before you actually watch me do it on this video. So I actually put these in the wrong spot. I made a mistake. We just did, what was it? We just did 5H. These are more so from G, so I actually put these on the wrong spot, but that's okay, because we've done G before, so it's just practice of things that we've already learnt. Okay, now you can see I've got B as underlined red because this is reasonably hard, and you can see Zach written there. That's because he asked me about it, so yeah, that's why that's there. Alright, but let's do A first. Let's not worry about B for now. Alright, so all we're trying to do here, as it says, is solve for x. Okay, now if we look at these two here, we can see that they're both log base 2. So if they have the same base, we can put them together, and we're taking this one away from that one. If there's that negative there, hopefully you can remember your log laws. If there's one log, take away the other log, we're going to end up dividing what's in here. Okay, so it's going to be that divided by that second one. So that's the first step that I'm going to do. Cool. So that should leave us there. Alright, now what I'm going to do right now is change it around to exponential, so I don't have this log anymore. So if I change it around the base 2, like it's still the base of the exponential, so it's going to become 2 squared equals whatever is inside here. Yeah, so 2 squared is 4. But we sort of need to get those x's together. So what I might do is just times this side by 4 minus x and times that side by 4 minus x. There we go. So let's expand these brackets and we should be able to get those x's together, I hope. Okay, so that'll give us 10 equals 3x. So x equals 10 over 3. Done. Okay, so let's have a look at this other one. Now this other one is a little bit harder. There's definitely a tricky sort of thing involved here. Okay, so like with A we're trying to solve for x, with B we're trying to solve for t, so we're doing a sort of similar thing. But it's a little bit confusing because we've got the t in a couple of different places. There might be a couple of ways to do it, but this is how I've ended up doing it. Now, I hate having this negative here. I don't like it at all. What I'm gonna do is try to get rid of it. So to get rid of this negative here, I could actually times the whole side by e to the power of t, because if I do, I'll write it just here. What's going to happen, because they're the same base, it's going to become 8e minus t plus t. So that's going to end up being 8e to the power of 0, and that's going to end up being 8 times 1, which is 8. Okay, so it's going to get rid of that negative there. So if I'm going to do it on one side though, I have to do it on the other side. So it's going to apply to all three of these terms. So we're going to end up having 3e2t equals 5e to the power of t, and then what we had over here as well, so it'll be plus 8. There you go. I'm going to move everything over to one side so we can kind of see what we've got a little bit better. Okay, now I can see that we have e to the power of t here. We've also got e to the power of t here, but like 2. So hopefully this looks pretty similar. We can end up changing this to a quadratic. So if we make e to the power of t equal a, that's going to be minus 5a. If we make e to the power of t equal a, that's going to be 3a squared. Doesn't matter what letter, I just like to use a. Cool, so hopefully you can see we've got a quadratic there. Let's factorize it so we can solve for a. I know a is not really what we want to solve for, but we're going to end up getting to where we want to be if we do that. So I split that middle term, and now I'm going to factorize by grouping, so you can use your cross method or whatever way you want to end up doing it. There you go, so it's factorized, and we can see that a is going to be 8 on 3, or a is going to be negative 1. So now we can change it back to e to the power of t instead of a. So make a equal, not 3 to the power of t, e to the power of t. Okay, let's look at this one first. Whatever t is, you're never ever going to be able to make it a negative number, so this doesn't work. Okay, but this one here, this is looking like it could be our answer, but we want to solve for t, don't we? So let's change this around to log form so we can make t the subject. Base is e, and there we go. That's it, done. Alright guys, have a go at the questions listed in the lesson plan that I've got there for you. The same as is written on the bottom of your page. So those ones just there. If you've got any questions, make sure you post it on the questions from students section of the team. When you see this, can you make sure you speak to the other students in the class, just to make sure everyone's getting or accessing Teams frequently or when they need to. I'm going to try to post on there pretty regularly. I want to make sure you guys are liking things when you see them, just to confirm to me that I know that you're seeing it, because I don't really want to ring you up or have to ring you up. Okay. Thank you guys. Make sure you post those questions if you have any. See ya.